All right, so now we're going to move on to part two of correlation, and that's talking about the math behind it. So, first of all, I need to say we're going to go over two different ways to calculate correlation. And for tests, you can pick which one you want. Both have their pros and cons, and we'll go over each of them as we're going through it. But the first way we're going to do it is by going over the covariance method, as I'm going to call it. And we call it the covariance method because it utilizes covariance. So in this case, the correlation that we are going to calculate is going to be equal to the covariance of x and y divided by the standard deviation of x times the standard deviation of y. Now, what is covariance, since we haven't got to that previously? Well, it's just the sum of all your x's minus the averages times y's minus their averages. So you take this value, multiply it by this value, add all of them up, and divide by n or n minus 1, depending on what you're doing, almost always n minus 1. So if we need to find or use covariance and then two standard deviations, well, you have to compute standard deviation for x and then standard deviation for y, so just like we did before. So we're going to go back and get into standard deviation again, and you will have to do this at least once. And then we're going to move into covariance. So how are we going to calculate covariance? Well, honestly, when you're doing the covariance method, it's not that hard. It's not that different from what we've already done. Because for standard deviation, it's the sum of x minus x bar squared over n minus 1. That's variance. And then you square root it to get the standard deviation. So we've already done a lot of what's in covariance. Really, we're just adding what we've done through x and y, and then just making one or two minor changes. So what we're going to do, and we're going to walk through the equation here, it's the sum of x minus x bar. Well, we have x's, we get the averages, then x minus x bar. So that's the first part. Then the second part is y minus y bar. We have y bar, y minus y bar. Then order of operations says we have to multiply them together, so we do that. We take the difference here times the difference here and get that. And you do that all the way down in your column. Then we add them up, the summation. And then the last thing is you will divide by, most of the time, n minus 1. So let's take the example of height and weight that we have used before. So I know that you can, well, hope you can already do standard deviation, but I'm going to walk through standard deviation for height first so I can show you how you can use your standard deviation calculation in your covariance equation. So for standard deviation, we have our 5 values. You're going to add them up, then you're going to get your average. You're going to put the averages in your chart, then you're going to take each value and subtract the average to get the difference. Then you're going to square those differences. Then you're going to add them all up. Then you're going to divide by n minus 1 and square root. And you've got your standard deviation. You've done this before. If this is going too fast for you, you probably will need to go back and look at the standard deviation lecture and practice problems. I'm assuming by now you've got this down. So you'll have to do this for both your x and your y values. So you get standard deviation for height, as we've done here, and then standard deviation for your y value, in this case, weight. So let's go through the example for the covariance. Well, we've already done this part when we were getting the standard deviation, right? We've already got our x values, we've already got the averages, and we've already got the differences. So if you have previously done standard deviation before doing this, you can just import those values into your chart. Now, if you want to be really careful, you can do it again just to double check your work on standard deviation, but it's going to be the same values. Then you'll put in the values for y, because we will have done standard deviation for, in this case, weight again. Now the difference that we need to do, the different thing we need to do in this chart really is now it's just the difference score times difference score for each one. So it'd be negative 0.2 times 21.4, value put here. Negative 8.2 times negative 50.6, value here, etc., etc. So it'll look something like this. So we've now done difference times difference for all of them. And now we have to add them all up and then divide by n minus 1. This is covariance. That's all you have to do. You have 3 charts: standard deviation for x, standard deviation for y, and then covariance. And once we've got that, we can move on and put everything together. So we've calculated covariance, we've calculated standard deviation of x and standard deviation of y. We'll just plug it in the equation. So covariance is 359.34 divided by 6.65 times 58.78. Well, when you do that, you get 359.35 divided by 390.77, which is equal to 0.92. Now, a couple things to note here. The first and most important one is a really good way to check your work, and probably the best way, we're not going to have other things like this throughout the semester really, is if you ever get anything that is either below -1 or above +1, you know you've made a mistake in your calculation somewhere. If covariance, this top value, is ever bigger than standard deviation of x times standard deviation of y, then you're going to get a value that is over 1 or over -1, under -1. You're wrong. You know you are wrong. And that's one of the reasons it's so important to know the properties of a correlation so you can double check your work. And it's not even double checking, it's just first checking, right? I mean, this is fairly straightforward stuff. But we've calculated correctly. You can work through it by hand if you want, or you can just trust me here. So let's now think about covariance a little bit. We're going to get into it some more when we on the next lecture when we talk about the model. But covariance tells us basically whether or not two variables are related and how. So if you have a positive covariance, it means as one goes up, the other goes down. And if you have a negative one, it means this is one goes up, the other goes down. So the issue with covariance is, and you've probably already picked up on this a little bit, covariance and variance, they're almost the same. Like with variance, covariance depends on units. So you cannot really, you can't directly compare covariances. So the covariance for height and weight, just because it's larger than the covariance between number of pencils and number of watches, it doesn't mean that there's more variation there. It just means that they're in different units. So we can't objectively compare them like we can when we get to correlations. Correlations are basically standardizing covariance, meaning getting rid of the units. That's one of the reasons we go to correlation and do the extra step above and beyond covariance. So you can compare the correlation between height and weight and the correlation between number of pencils and number of watches, and you can say whether or not one correlation is stronger because all correlations are on the same units. Okay, now we're going to move on to the second way, which I'm calling the computational method. And the reason I'm calling it the computational method is you've got one, you have one equation. And it at first looks difficult and scary, but it's not really that bad. I actually prefer to do it this way when I'm just trying to calculate something. So we have this single equation. So for the single equation, you actually need only one relatively small chart in order to get it done. And we're going to walk through this relatively slowly, so try to watch on here. So in the numerator, we have n, which is just the number of pairs we have, the number of people, so the number of rows. Then you are going to multiply that times the sum of x times y. Well, we are going to find the sum of x times y eventually, so it's just going to be this value here. Then you're going to subtract the sum of x, which we are going to get here, times the sum of y. Then we're going to divide it by the square root of, we already have done n before. Then we're going to multiply it by the sum of x squared, which we're going to get. And then we're going to take the sum of x and square it. And then it's going to be the same thing for your y values. And again, the sum of y squared, and then the sum of y squared. So it's really no big deal to do this. It's one relatively modest table and one not that difficult equation. The difficult part in the equation is just making sure that you go step by step carefully so you can get it all done. So in the case of height and weight, we can plug in our values of x and y. Then we can get our x squared, so you simply take 70 and square it, 62 and square it, 66 and square it, etc. Then you do the same thing with your y values. So 215 squared, 143 squared, 130 squared. Then we do the sum of x times y. I'm sorry, we just do x times y. We'll get to the sum of x times y. We do x times y here, x times y here, x times y there, etc. And then we have to add them all up. So we will take 70 plus 62 plus 66 plus 79 plus 74, add them all up, and we're going to do that for every column. Once you've done this, you are just going to plug and chug, plug these values into the equation in the appropriate place. So we have our equation, we have our chart. Well, we're just going to plug it in. We have 5 people, 5 rows of data, so we have 5. The sum of x times y, 69, 391. Subtract it times 351, which is the sum of x, times the sum of y, 968. Over the square root of n, which is 5, times the sum of x squared. The sum of x squared is 24,817, minus the sum of x, and then we're going to square it. Then we do the same thing for y values. N, which is 5, sum of y squared, which is 201,224, minus 968 squared. It's the sum of y squared. And once you've got that, it's just straight algebra. You're going to multiply these two together, then subtract those two multiplied together. You're going to multiply these two together. You're going to square that, multiply, square, and then subtraction for each side. Then multiply them together, and then square root. We're going to work through it step by step. So we have our equation at the top. We have our values plugged in. Well, now we're just going to do step by step. So 5 times 69,391 is 346,955. Subtracted, and those two multiplied times each other is this value, 339,768. 5 times 24,817 is 124,085. Subtracted by 351 squared is 123,201. Then in the next bracket, you're going to do the same 5 times 201, 224, minus 968 squared there. And now, once we've done that first step, really all we have now is we have subtraction, subtraction, subtraction. Then we'll have multiplication, square root, and then division again. So 346,955 minus 339,768 is 7,187. Divided by 124,085 minus 123,201 is 884. 100,120 minus 937,024. Ooh, these numbers are getting big, is equal to 96,096. Next step, we just multiply those two together, and then we square root them. And then we are left with one division, and we get our correlation, which is equal to 0.92, which, as you will possibly remember from the covariance method, is the same way. You get the same correlation no matter what. It's just the math is a little different. So, which one are you going to do? Well, you can pick, but let's think for a minute here about the kind of pros and cons. So, covariance method gets you standard deviations, which you're probably going to want for other things. For example, when we get to regression, you're going to need standard deviations. So if you have to calculate standard deviations, you might as well do standard deviations in the covariance method instead of doing the computational method and then having to go and get standard deviations as well. Additionally, this is more conceptually what you want to understand what you're doing. Covariance, just the term covariance and what it does is an important way to think about your data. As one value is changing, another one does. And like I said, in the next lecture, we'll get into that in more detail. But conceptually, it's a little more where you want to be. On the other hand, the computational method is more straightforward. It's one table, one formula, you get through it. Another downside to the computational one that you probably saw already is depending on the numbers you're dealing with. If they are large numbers, you're going to deal with really, really large numbers because you're adding all of your values up and then squaring them at times. You're multiplying large quantities together. So it can get very, very big very, very quickly.